You know that feeling, right? You're looking at some complex piece of software and you think, hey, we could totally build that ourselves, but better. It's so tempting, isn't it? The promise of that perfect custom fit solution. But what happens when that ambition slams into the cold, hard reality of actually doing it? Today, we're going to break down a case study of one of those projects and explore the hidden dangers that can turn that dream into a very, very expensive nightmare. So, let's get into it. Our story really kicks off with this simple, almost baffled question between two industry experts. They're watching this massive company try to build its own incredibly complex control system from scratch. And just looking at the sheer risk involved, one of them finally turns to the other and just asks, why? Why are they even doing this? And the answer he gets back is just one single word: ego. Wow, that's a bold claim. But is that just a cynical hot take? Or is there some real evidence to back it up? Well, that's what we're here to find out. To really get to the bottom of that one-word answer, we have to start by looking at the evidence. And we're kicking things off with the technology itself. Because the real story of a software project, well, it's not in what you see on the surface. It's in all the stuff that's hidden away. This slide just nails the two faces of this project. On one side, you've got the showcase UI. That's the flashy part. It's pretty, it's easy to demo to execs, it gets all the attention. But the other side, that's where the real danger is lurking. These are what we're calling the real hard UIs. They're the complex, ugly interfaces that only a few core employees ever see, and they're where the entire system stability hangs by a thread. First up on our tour of hidden nightmares is the configuration UI. You should think of this thing as the system's brainstem. Every tiny variable, every dependency, it's all managed here. It is a total minefield. One wrong toggle, one typo in a database connection string, and bam, you can trigger a chain reaction that takes the entire thing offline. Next, we have the maintenance UI. This is your, oh no, it's 2 a.m. and everything is on fire panic button. It's literally built for worst-case scenarios. And just think about how unbelievably hard it is to build a tool that's supposed to solve problems you can't even predict yet. Then you've got the log visualization UI. Okay, the challenge here is just huge. You have thousands, maybe millions of lines of messy, cryptic server data. And your job is to somehow magically turn all that gobbledygook into a coherent story that a human can actually use to figure out what went wrong in real time. Good luck with that. And this brings us to a classic trap, the scripting UI. See, the goal is always to build something simple, something user-friendly. But your power users also need it to be, well, powerful. So they'll inevitably try to break your simple tools to write raw code, which puts you in this constant tug of war between simplicity and power. And believe me, the list just keeps on going. Management UIs, troubleshooting tools, workflows for acquisitions, each one of these is a huge, high-stakes project all on its own. And they all have one thing in common. They're almost always an afterthought. They're built with zero budget for polish, and they're used by the very people whose jobs depend on the system not breaking. The sheer volume of this hidden work is it's staggering. Okay, but all this complex, brittle code doesn't just write itself, right? It has to be built and maintained by people. And that brings us to the second, and honestly, maybe the scarier part of our evidence: the human cost of building a system like this. This leads us to a concept you've probably heard of: the hit by a bus factor. It sounds a little grim, I know, but just think about it. What happens if your one genius developer, the one who knows all the weird quirks of the system, wins the lottery tomorrow and quits? In a custom-built system, that critical knowledge isn't written down anywhere. It leaves in their head, and when that person walks out the door, poof, it's gone, forever. And this isn't just some hypothetical problem. The research is clear: teams with high turnover accumulate 37% more technical debt. Let that sink in for a second. Every time a key person leaves, the system doesn't just stagnate, it actively starts to decay. It rots from the inside out because the knowledge to maintain it properly is gone. And this is how you fall into what's called the automation trap. It always starts with the best intentions. Step 1, you build some clever scripts to save time. Awesome. Step 2, the people who built those scripts leave and nobody else really knows how they work. Uh-oh. Step 3, the scripts eventually fail, so they get patched with a quick, dirty, hot fix. And finally, you reach step 4. Maintaining the fragile, patched-together mess of scripts now takes more time than the original manual task ever did. The lesson here is so important.
automation without documentation and shared ownership isn't an asset, it's a ticking time bomb.
So, if the technology is a minefield and the human cost is incredibly high, we have to go back to that original question. Why do it? That brings us to the motive, which seems to be a toxic combination of flawed financial logic and dangerously broken team structures.
And here it is, the core driver, laid bare. The whole point of the project is cost reduction. But look closer at that ideal. Self-operated is one too many operators. This isn't just about being more efficient. The ultimate goal is elimination. They're aiming for a perfect system that requires 0 human operators at all.
But this creates a massive paradox. The attempt to save money by building this super complex autonomous system ends up creating something so brittle and fragile that its maintenance costs just spiral out of control. When it fails, and trust me, it will fail, the complexity is so high that the organization gets trapped in this endless, expensive cycle of just patching and debugging. This flawed strategy also creates totally misaligned teams. First, you get this problem. When the builders are the maintainers, it's bad. This means the people who built the system are the only ones who can possibly fix it. There's no separation of duties, knowledge is trapped in a tiny silo, and that bus factor risk we just talked about, it goes through the roof. And then it gets even worse. When those same key engineers, the maintainers, are also forced to be the day-to-day operators, you have an even bigger disaster. They get pulled away from crucial strategic work to just fight fires all day. Innovation grinds to a complete halt because your best and brightest minds are trapped just trying to keep the lights on. So, we've looked at the technology, we've looked at the people, and we've looked at the motive. It's time to circle all the way back to where we started and deliver the final verdict on that single one-word explanation. And now, we can finally see that ego wasn't just about individual pride. It's about organizational hubris. It is the collective belief that your company is the special exception, that you can succeed where so many others have failed, that you can somehow defy the immense technical, financial, and human complexities that make these projects so notoriously difficult. Ultimately, the stakes just could not be higher. This is what's truly on the line when that kind of hubris takes over. It's not just the wasted money and the wasted time, which are significant. It is the absolute loss of credibility, both internally with your staff who get completely burned out and externally with the industry that sees the failure.
So where does all this leave us? Building your own tools? It really can be a path to true innovation. But as we've just seen, it can also be an incredibly expensive trap. The real challenge then is for all of us to honestly ask ourselves, are we building something because it's a strategic necessity, or are we just feeding our own ego?